Should be ready to check your answers to the warm-up, so make sure you have your grading utensil out. So number 1 said to find all possible rational roots. They're not actually for asking any specific one, which means we're not using synthetic division here. Okay? So we look at our constant. And the LC. Well, the constant in this expression is the 6, and it's okay if it's negative or positive. And the lead coefficient, well, our highest exponent is 4. The lead coefficient with that is a 1. So factors of the negative 6, we know we have 1 times 6, so plus or minus 1, and then plus or minus 6. And we also have plus or minus 2 and plus or minus 3. So there's the factors of the 6. Now of 1, well, we only have plus or minus 1. Now remember, we take all the factors of the constant and we divide them by whatever factors of the lead coefficient there are. Thankfully, this one only has 1, so it's a little bit easier. So we start with 1, and now we're dividing it by 1. So that's plus or minus 1. Then we have the next one, which is 2, dividing that by 1, which will give us plus or minus 2. Then we move on to 3 divided by 1, so that'd be plus or minus 3. And then last but not least, our 6, divide that by 1, we're looking at plus or minus 6. So there are all the possibilities. Remember, it didn't say to find a actual root, it just said the possibilities, which is what you have right here. To find the actual ones, you would then take those numbers and plug them into synthetic division until you had a remainder of 0. Looking at number 2, this one you didn't have on your homework last night, but we did cover it in notes briefly. So we're looking for additional roots. Well, remember, additional roots only occur if you have a radical or the letter I. If you don't have that, ignore the 5 under the radical, just the radical sign, then you don't have an additional root. So the first one we run into does have a radical. So since it's a positive square root of 5, we know we would also have a negative square root of 5. The next one has an I, so that also has an additional root. Since it's a positive 3i, that means it's negative 3i. And our third one is a negative 5. Well, that doesn't have a radical. It doesn't have an I, so there would not be an additional root for that one. So the only additional roots would be negative square root of 5 and negative 3i. Here are the answers to your homework last night, 1, 2, and 3. We got your directions didn't say to find any actual roots. We were just listing possibilities. So there I have listed the factors of the constant and the LC for each one. And then remember, it's the constant divided by the LC, and you have to make sure you mix and match each one. So there's your answers to 1, 2, and 3. On 5 and 6, you were finding a actual root, not all. So as long as you have one of these 3 as your actual root, then you're good. Now remember, these are not all of the possibilities. For number 5, you'd also have had possibilities of plus or minus 3. Number 6, they actually were all the possibilities. But any answer, you only need one of these as your final answer to have the problem correct. So you could either have 1, negative 1, or negative 9. Or on number 6, you could have had 1, negative 1, or a positive 7. All the other possibilities did not work. They were not actual roots. we're going to wrap up 3 for today, and then tomorrow you're going to spend time in class practicing it to make sure you can get help as needed. So today we're writing a polynomial function using the conjugate root theorem, which is what we worked on yesterday, where we did in number 2 on your warm-up, and given roots in case they don't have a conjugate root. Well, the first thing we're going to do is we're going to plug the zeros into the factors. And then to get our polynomial function, we're going to take those zeros and double distribute or FOIL, whichever way you prefer to say it. So we actually have done this before. Now we're just doing it with square roots and letter i's. Now, a couple things to remember is I squared equals what? This was something you're supposed to memorize, and it equals -1. So if you don't remember that, write that down because that's going to show up here. So our first example is the root of 3i. Well, the first thing I have to figure out is, would there be an additional root or not? Well, remember, to have an additional root, we're either looking for a square root or an I. This does have an I, so if I have 3i, I also know that I have -3i. Well, I put these into my parentheses, and remember the parentheses, we put them in as the opposite. So if I have a positive 3i, that means it had to be a -3i in the parenthesis or a minus. And if I had a -3i, then that means in the parenthesis it had to be a positive 3i. So here are my zeros plugged in. Now we're going to FOIL or double distribute here. So we have x times x, which is x squared, x times 3i, which is 3ix. Imaginary comes before variables. Then we have -3i times x, so -3ix. And then last but not least, the -3i times 3i. Well, the 3 and -3 make a -9, and I times I is I squared. So now we start to see what we can simplify. Well, if I look in the middle here, 3ix and -3ix should cancel. And because these are conjugates, that should happen every time. So now I have x squared minus 9i squared. Well, remember, we brought up the fact that if you have an I squared, that does actually equal -1. So that means I now have x squared minus 9 times -1. Or, if you remember from before, that really just means that this -9 turns the opposite. So it becomes x squared plus 9 is your polynomial function. Our next example, they give us 2 roots. Well, we have 3i and -i. So the first question is, will there be any additional roots? Well, I have an I, so that means yes. So 3i means I also have a -3i. Here I also have an I, but it's a -i, which means I also have a positive I. So we're going to have 4 parentheses this time. So we're going to have an x minus 3i for the positive 3i, and x plus 3i. Then, for this second set, we're also going to have x plus I, because inside the parenthesis we put it in as the opposite, and x minus I. Well, remember, when we're doing this part, the conjugates, the 2 middle terms are going to cancel. So we can go ahead and not even write them. So we have x times x, which is x squared. And then we have -3i times 3i, which is -9i squared. because again, if you did your middle terms, they would cancel. You could still multiply them through if you'd want, but if they're going to cross out, why take the time? Well, remember, I squared turns into a -1, so that means this parenthesis is going to become x squared plus 9. Now we work on the next two parentheses. So we're going to go x times x, which is x squared. Remember, these are also conjugates, so we don't even need to do the middle. We just need to also do I times -I, which is -I squared. So this parenthesis is going to become x squared. The minus turns to a positive, and again, I squared is the 1. So now we double distribute with these two parentheses. So we go x squared times x squared, which is x to the 4th. X squared times 1, which is x squared or 1x squared. 9 times x squared is 9x squared. And 9 times 1 is 9. So now we look for our like terms. X squared plus 9x squared, that turns into 10x squared. Plus 9 is your final answer. So in this one we had to double distribute not just once, but actually 3 times. Our last example is the square root of 2. So the first thing we ask ourselves is, would this one have an additional root? Remember, if it has a square root or an I, it does. So the square root of 2, the additional root would be negative square root of 2. So now we put these into the parentheses. So we have x minus the square root of 2, because again, it's always the opposite. And then x plus the square root of 2. Now we double distribute. So x times x is x squared. X times the positive square root of 2 is square root of 2x. Inside, negative square root of 2x. And then we've got negative square root of 2 times the square root of 2, which is negative square root of 4. Well, remember, they're conjugates, whether or not they're i's or radicals, so these should still cancel. So again, we didn't have to multiply them. So I have x squared, and then I have minus the square root of 4. Well, I know what the square root of 4 is. It's 2. And think about that. Since we were multiplying square root of 2 times square root of 2, the square roots, since they're the same, would cancel, leaving you with that number inside. If you don't remember that, you can still multiply them together and then just take the square root of that number. Here's your homework for tonight. You're doing exactly what we just did. Now keep in mind, there's only additional roots if there's an I or a square root of 2. So if they don't have that, then you do not put more roots in the problem. You just use the ones they gave you. So for example, if I look at number 7, does -2 have an I or a square root? Nope. So you would only have the -2, and the same thing with the -8. So I'll start that one for you. So since it's -2, you would have +2, because again, parentheses, it's the opposite. And then since it's a -8, you would have an x plus 8. No other roots, because there were no i's or square roots. So go ahead, take a picture, write these problems down, or again, log on to YouTube, go to my channel and find this video, and the problems will be on there.